So we're here with Dr. Matthias Broecheler, and you're going to be the keynote speaker tomorrow at Graph Day, and I know a lot of people are excited about that. We have a pretty decent graph turnout,
Yeah, it's exciting.
Yeah, very exciting. And so, can you give us a little synopsis of what you're going to be telling them tomorrow?
So I'll try to talk about sort of how graph is being used. I think we're now on the last stage of sort of proving out the early adopter market for graph.
Okay.
So we're going to try to look a little bit at when are you going to be successful with graph and when are you not going to be successful with graph.
Okay.
Right? So to kind of delineate what are good use cases to go after with graph and what are not so good use cases.
Okay.
Because there's still a lot of confusion about what graph is and what graph should be used for.
Yeah.
So I'm trying to make that a little clearer.
Nice. Is it possible to sort of put that in a nutshell for the audience here and say, generally speaking, or is it really they just come into the talk for a couple hours?
They should come into the talk. It's not a couple hours. I'm trying to keep it to 40 minutes.
That's not what we heard.
But I'm going to try to keep it to. The bottom line is really trying to look at two broad different types of use cases. One is more in the real-time arena where you're using graph as a replacement for relational data stores.
Okay.
Where your data is too complex to fit into a relational data store, or it becomes too unproductive for developers to use a relational data store.
Okay.
Because of data modeling concerns or just agility around developing queries and the like.
Okay.
And the other one is looking at graph databases from a perspective of building a data product. So if you have a data science team and you're trying to launch a data product, there are some good use cases in the category of data products where graph databases are really useful and can help you a lot in transitioning data science products into the market.
Well, and your PhD is graph theory.
It's graph theory and then graph database applications, so like kind of proving out the basic fundamentals of how to build such a thing.
Yes, yeah. So this is quite possibly one of the most important talks of the new year. It's like 2016. I mean, we're still early into the year, but I still put it among the top. So
I hope that people are going to get something out of it for sure. We're really the exciting part about tomorrow is that this is the first time we're going to have a conference that focuses on graph database technology from a vendor neutral point of view.
Yeah.
And that's what makes it really exciting, because it's not like just one vendor trying to sort of push their message out. It's really a bunch of people come together that have been using graphs, that have been proving out graphs in actual use cases, and trying to distill what this really is. We're still at the stage where it hasn't really been fully defined.
Right.
We know what the technology does, but we don't know how it can be used to build things that before we thought were impossible to build.
Right.
And so tomorrow we're going to see all these people come together and hopefully get some synopsis of, this is what it is.
Yeah.
And then 2016, 2017, 2018 will be about really proving it out.
Well, and just being here for the last 24 hours, I had seen use cases for graph data that I'd never imagined. I don't know. It was just a head scratcher, and some of this even I have to visualize. I have to see it to see what's going on. So I feel like there's just top talent here, and a lot of insight. I know there's people who are watching the video right now, and they're like, graph, isn't that just taking numerical data and making a bar?
Bar charts.
Yeah. And for them, how would you succinctly tell them, no, it's different?
Yeah, it's actually funny. So I used to start my presentations with, like a screenshot of Microsoft Excel and saying this is not what we're talking about. This is not necessary anymore. So we've come to the point where a lot of people now understand the difference between charts and graph data. But generally, what we're talking about is highly connected data. So you have entities in your data, and you're trying to connect them in various ways. So think about Facebook, social network, security, where you have networks and routers and ports and machines and things connecting, sending packages and the like. So the kind of data where things are connected in very complex ways, and you're trying to reason about it. You're trying to understand what is going on from a security perspective. Is somebody trying to intrude my network? On Facebook, you're trying to figure out how can I target, how can I best personalize content for this individual? They're in healthcare, personalized medicine, where you're trying to understand the broader picture around a patient. Yeah. So those are the kinds of use cases where graph can be really useful to capture the complexity in the domain and make it possible for us to reason about it.
Right, as far as making those relationships versus the old trying to join these millions of different tables and that sort of thing.
So there's the technology part where obviously we're doing a lot of things under the hood to make it possible to actually do these things. Right, relational databases are very handicapped when it comes to doing multi-way joins on very large tables. Things basically come to a halt. So you can't really do it, and that's why people haven't done it on the technology side. But there's also the other side of the equation where it's about individuals, human beings being enabled to actually do that kind of analysis. Because if you have to write a 7-way join query in SQL, that's going to become a head scratcher pretty quickly, right? And nobody knows what's going on in the query. So it's also a lot of innovation on the query language side with Gremlin, Tinkerpop, trying to figure out how can we build a query language that makes it possible to do all these really interesting things, but in a way that humans can still understand them and write them and reason about them.
Right.
So that's the other part of it.
At least until we have artificial intelligence that's doing all that thinking for us. Right?
Yeah, that's going to be 2019 probably, like when we...
Okay.
No, I think that's further out because I think some of the things that you're doing with Graph are go towards artificial intelligence. Like there's a lot of interesting things where when you look at network dynamics, like the emergence of network dynamics seems almost like an artificial intelligence.
Yeah.
Right? Because you look at sort of individual node dynamics and they're very easily describable. It's like simple nonlinear dynamics. But then when you put it together in a massive system, the system as such behaves completely differently in very complex ways. And you start to wonder, wow, how could I get all that complexity with just a sort of a simple graph representation? So there's a lot of magic to graph in that regard. So I think graphs are going to play a role in actually enabling artificial intelligence.
I can see that definitely. So, and well, with that, talking artificial intelligence, talking 2019 or however long we have until then. Before we get there, what are some of the major sort of leaps that you see have to be made, or major improvements or evolution that you see maybe in the next just couple of years?
So one area that has kept me busy for more than 5 years now, and will keep us busy for many, many more years, is trying to figure out how to partition graphs.
Okay.
Right. So when you try to scale a system, at some point you need to partition the data, right? Because you cannot just scale up one machine indefinitely. It becomes too costly to do that.
Yeah.
And so a lot of the things that people talk about here is about how do you chunk up your data so you can put it on individual machines and then build these large clusters. Now for data that where you can basically hash a key and then put it somewhere, that's pretty easy to do, right? So there's lots of hashing out there, and there are complexities to it, but by far and large we understand how to do this.
Right.
For graph, where everything is connected to everything potentially, it is a much more difficult problem to figure out which parts of the graph go where, so that I can somehow chunk it up. You can never fully partition it, but partition is sort of in the best possible way. And that is a really, really hard problem. Computer scientifically, it's NP hard, but even just in practice, it's very hard to just sort of wrap your head around it and try to come up with systems that work well enough in practice.
Right.
So that's an area that's going to keep us busy.
There's no clean breakpoint. It's just kind of fractures.
No, it's not like you have two graphs and you just say, oh, one goes here, one goes here. It's it's like a big spaghetti bowl, and you have to cut it at some point and say, this part goes here, this part goes here.
That noodle goes in.
Yeah, right. Where do the noodles go?
Yeah.
And then you want to have the exact same amount of meatballs everywhere.
Right.
Otherwise, people get upset. And so that's kind of the same with graphs. You really, because if you don't do a good job at it, then you have machine overload. Like one machine gets all the traffic, and the other machines are just sitting idle.
Right.
And you don't want that. On the other hand, you also don't want to randomly partition, which is typically the best way to do it, because then you get lots of cross-machine traffic, because all the different nodes in the cluster need to talk to each other. And as you scale out, that becomes an n-squared number of connections, and then things just come to a halt.
Wow.
And so that's been the biggest bottleneck for adoption of graph in large-scale use cases. That's why you currently only see graph mostly in use cases where you can scale up. So you just buy bigger and beefier machines.
Right.
But that also hits limits, obviously.
Right. Well, I'm really excited to see what sort of discoveries. You spent the last 5 years working on this. Probably in the next 2 years, you'll have it nailed down.
Of course. Yeah.
And then maybe
optimism dies last.
And then maybe at Data Day 2018, you'll be giving a paper about how you've solved that issue.
I'll tell you all about it. Yeah.
All right. Well, we appreciate that. Dr. Matthias Broecheler here talking about his keynote tomorrow, and we appreciate your time.
Absolutely. Thank you.
Thank you.